All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.8 in Pre-Calc, which is the last section of Chapter 4. This is our first video, so we're going to go ahead and work through some trig applications and modeling. So in this section, we're going to be doing a lot of word problems. I know you're totally stoked. So we'll have a lot of degrees, not radians. Most word problems in the real world tend to talk in degrees, right? So if a plane's flying upwards at a 60-degree angle, people are going to look at you weird if you say at pi over 3, right? If you tell somebody to take a 90-degree turn, right, they're going to look at you weird if you say a pi over 2 radian turn. So most of the time when you see word problems, they'll tend to be in degrees. So in fact, I'm just going to go ahead and jump over to the calculator and recognize that I'm probably going to be in degree mode, so let's go ahead and switch this to degrees. And that might change, but most of the time we're talking degrees when we do word problems. All right, so let's do two bits of terminology really quickly and notation. So the phrase solve the triangle means find all the measures of the angles and the three sides, right? Now all of our triangles here are right triangles, so we know one of the angle measures automatically. We'll solve a few triangles just before we get into this word problem action. When labeling triangles, the convention is that if you label the vertices, right, these corners, if you label them with a capital letter, you label the side opposite them with the matching lowercase letter. So the side opposite C would be called lowercase c, the side opposite A would be called lowercase a, and the side that's not touching B would be lowercase b. I find it really helpful to write a little table of those values when I'm solving a triangle, and I put them in a specific order, like angle A is next to A, and angle B is next to B, and angle C is next to C, so that I make sure I don't forget anything, and it just helps keep things in order. This is also going to be a really helpful skill when we get to Chapter 6 in Pre-Calc, and we start talking about solving triangles that are non-right. Okay, so we're going to go ahead and solve a triangle, which means find all the angles and all the sides. So what I'm going to do is I'm just going to make a list of the stuff I know. I don't know angle A yet. I do know angle B, it's 62 degrees. I do know angle C, it's 90 degrees, right? So when I label this, this is little b, right? This one's little a, and this one's little c. So I don't know little a. I do know little b, right? It's 22.6 miles, right? And I don't know little c. So I'm going to go ahead and find these values. So the first thing that's easy to find is a, because the angles in a right triangle, or the angles in any triangle sum to 180, right? So these angles sum to 180 degrees, right? So basically I can just do a 180 minus the 90 plus the 62, and I should get that this is a 28 degrees, right? Make sure you have the degree symbol. So that's the first thing I would do. I would go ahead and find that using the sum of the angles in a triangle. And then after that, I'm going to go ahead and find any one of the sides, right? It doesn't really matter which one. I would argue, so I'm going to go ahead and find A. So I'll find A second. That's the second thing I'm going to do. And to find A, I'm going to go ahead and use this angle, right, and this side, because that's the information I know, right? I could also use the other angle. It really doesn't matter. I guess if you want to make your life slightly easier, you could use the 28, because then tangent works better. But I noticed that this is the side opposite the 68 or 62, and this is the side adjacent. So I'm going to use tangent. So I'm going to say the tangent of 62 degrees. This is my second bit of work. Tangent of 62 degrees equals the 22.6 divided by lowercase a. When I multiply the a over, because remember, tangent of 62 degrees is just a number, right? I can divide by that number and get that a should be whatever 22.6 divided by the tangent of 62 degrees is, right? And I'm going to go ahead and type that in my calculator. I've already changed to degree mode, right? Divided by tangent of 62. All right, so I'm going to get that this is a 12.016 or 7 miles. I recognize that the original only gave me to the tenths place, but we always go to the thousandths place. So there we have that. Now I'm going to store this as alpha A, right? I'm going to store this as A in my calculator. I'm going to make a note that I did that, right? I'm going to make a note that I stored this as A. Because when I go to find C, there's a couple different ways to find C. I could find C using a trig function if I want, right? I could easily find C using a trig function. So this is the last thing I'm going to find. I could either use trig, or I could use Pythagorean theorem, right? I could use Pythagorean theorem with B and A, because I know A and B now. It really doesn't matter to me which one you're going to pick. I'm going to go ahead and do some trig, right? I'll go ahead and do sine. So I'm going to, for my third attempt, and I didn't end up needing this A, but I might sometimes, so it's worth storing. So I'm going to go ahead and say that the sine of 62 degrees is the opposite, which is the 22.6 over the hypotenuse. So I'm basically going to solve the same way by multiplying the c over and dividing the sine value. So I'm going to get that c is 22.6 divided by the sine of 62, degrees. So what's cool about that is I can actually just hit second enter a couple times and then replace the tangent with a sine because it's the same problem, right? So I can just go over tangent and hit sine, and that'll give me a value. And I'm going to get 25.596 miles approximately, right? And I'll put a squiggle there and a squiggle here. Now, a thing to note, the way triangles work, the biggest angle is opposite the biggest side. So see how the 90 is the largest angle measure and it's opposite the largest side, which is the 25-point stuff. The next biggest angle is opposite the next biggest side, and the smallest angle is opposite the smallest side. That's worth doing a quick check because sometimes that helps you spot that you typed something in a calculator wrong, right? Or that something went slightly awry. Okay, so I solved the triangle, I found all those values. All right, so you're gonna go ahead and try one too. Again, I'm gonna suggest that you make a list, right? Angle B, angle C. So I know angle A is 51 degrees. I know angle C is a 90-degree angle. So the first thing I'm going to find is B, right? And then if you list this, you know little a, you don't know little b, you don't know little c. So you know little a is 9 inches, right? You don't know little b, you don't know little c, right? So if I were you, the first thing I'd do is find b, right? I'd say, cool, this has to sum to 180. So I'm pretty sure I get a 39 degrees, right? And the way I did that, honestly, is I knew I'd already used up 90 degrees, so I just did 90 minus 51, knowing that 90 of the 180 degrees was already used, so this has to be a 39, and that's where I got that. Once I have that, I'm going to go ahead and find B and C, right? So I know the 51, and I know the side that's opposite the 51. So basically, to find B, right, which I'll do in blue, I can say that B is the tangent of 51, so this is my second thing. Tangent of 51 degrees is the opposite, which is 9, over the adjacent, which is B. So again, I can multiply that B over and divide by the tangent, and I'm going to get that B is 9 divided by tangent of 51 degrees, which I'm going to type in my calculator. I can do the same thing, right, for C, but I notice that C is the hypotenuse, so I'm relating the opposite to the hypotenuse. So for the third one, for C, I'm going to use sine. I'm going to say sine of 51 degrees equals the opposite, which is 9, over the hypotenuse, which is C. And again, I can pull that same trick where I multiply C over and divide the sine. So I'm going to get that C is 9 divided by sine of 51 degrees, and then I can get an approximate value. So I'm just going to go ahead and get an approximate value for both of those. So 9 divided by tangent of 51. And again, make sure you're in degree mode. So for B, I'm going to get that this is approximately a 7.288 inches, right? And I make sure I have units because there are units in the problem. And then if I hit second enter and just change that tangent to a sine. Oh, I didn't mean to. I deleted some stuff, but that's all right. Change that tangent to a sine and hit enter. And I get that this is an 11.580 or 1 inches. And again, do a quick double check. The biggest angle is the 90 and it is opposite the biggest side. The smallest angle is the 39. It's opposite the smallest side, so that checks out, and there's my answers, right? Always worth doing a quick double check. All right, we'll do 2 more of these, and then I think that'll actually be the end of this video, and then our next video we'll do some word problems. So again, really worth listing all of the things, and it's not always A, B, and C. Sometimes it's D, E, and F, or sometimes the letters have significance in a particular problem. Like F might stand for fire station, or P might stand for police station, or S might stand for school. But in this instance, they're just A, B, and C. All right. So here's what I know. I know little c is 5 meters because that was given, right? I know big B is 53 degrees. I know big C is 90 degrees, right? And that's all I know, right? So this is little a and this is little b. So let's start with finding the angle, right? I know these things sum to 180 degrees. Since 90 of that is already used up, I need the 53 to sum to 90 with the other missing value, so I'm pretty sure that's going to be a 37. All right, so again, the way I got that was by doing 90 minus the 53, because I recognized that I'd already used up 90 of the points with the right angle, right? So to get the others, right, again, I'm going to set up, I know this is the hypotenuse, so basically I'm just going to use sine and cosine, right? So, so to go ahead and get A, right, relative to the 53, A is the adjacent and B is the opposite. So sorry, that's not a 1, for my second step of solving, right, the cosine of 53 degrees is A over 5. So 5 cosine of 53 degrees will give me A, right? And then I'll find a value in a second. And then to find the other one, right, to find, we'll call it this guy number 3, right, I would set up that this is the opposite side, right? So sine of 53 degrees is the opposite, b over 5. So I'm just going to type in 5 sine of 53 degrees, and that'll be my b, right? And then I'll find a value for that. So let's go ahead and do 5 cosine of 53, right? And that's approximately, let's see, the cosine was the one I did in red. So that's about a 3.009 meters, right? And then the one I did in green, we're going to go ahead and do 5 sine of 53. And hit enter, and we get that this is about a 3.993 meters. And again, do the quick double check. Make sure that you write the approximate symbol if they are approximate. Do a double check that the largest angle is opposite the largest side, the smallest angle is opposite the smallest side, and it is. So those are my answers. All right, so we'll do one more of these, and then it's word problem time. All right, so go ahead and give this a try, right? We have angle A, angle B is a 28 degrees, angle C is a right angle, right? Little a is the side I do know, right? Because this is the side opposite A, right? I don't know little b, I don't know little c. And it's a pretty safe bet that you're rounding for both of these, so I guess I could just put a little rounding symbol. All right, so again, I'd start with the angle. You don't have to, but I would suggest that the first place to start is to find this missing angle. So I'm going to recognize I've already used up 90 degrees, so if I just do 90 minus 28 degrees, I think I get a 62, right? And that'll be the missing angle. To find b, right, so here's little b. Little b is opposite the 28. Little c is the hypotenuse, right? And little a is the adjacent. So, so in order to find b, right, so we'll call that number 2. In order to find b, that's opposite over adjacent. So I'm going to use tangent, right? So tangent of 28 degrees is the opposite, b over the adjacent, which is 6. Sorry that my 6's always kind of look like b's, which is not a great combination, and I can't really make it a capital V because that has a different meaning in this problem. So 6 tangent of 28, it's usually how I get around the 6 and b's issue. All right, so I get 3.190 inches, right? And then if in red I do the last one, right? So to find c, c is the hypotenuse with the adjacent, so I'm going to use cosine, right? So for the third thing, I'm going to say the cosine of 28 degrees is the adjacent 6 over the hypotenuse c, and this is going to be that situation where I multiply over and then divide this back. So c is going to be 6 divided by cosine of 28 degrees, right? So 6 divided by cosine of 28 degrees, and I'm going to get 6.795 inches. All right, and I think that that's it for this video.